Okay, so let's get started. We want to build and build and train artificial neural network in Python, and we want to do it with SciKitLearn first, and then with a stronger and more powerful libraries such as Keras and TensorFlow. So first, with scikit-learn, this is very similar to other machine learning algorithm. The structure is pretty much a standard way for training and testing. To import artificial neural network model, we from scikit-learn.neural-network, we import MLP classifier. Multi-layer perceptron classifier is the name of the class that scikit-learn selected for artificial neural networks. I import a train test split to split the data, and then I will try it using cross-validation, so cross-val, and I will use accuracy score to check the accuracy of the model later on, and plot some curve using matplotlib. Okay, so for this, so let me run this to import all of these things. In this example, I again use this data set that we had before, and the cancer with 9 features. I read it from GitHub, and these are the features that I defined. So the features are similar to before, the same features that we had in previous tutorials. And the goal, so these are the features that extracted from a medical image, for example from an ultrasound, or from CT scan. And then the goal is to design a machine learning algorithm that can predict if this is a malignant cancer or not. So let me run this, and then like before, I split the dataset into testing and training, and this is how I can define my neural network. So my ANN will be the neural network, my model. It will be from this class, MLP classifier. So this term right here, it means that your network has one hidden layer with 3 neurons in that. Okay, this is what it means. So this term right here, I explained it. The ith element represent the number of neurons in the ith hidden layer. So in this specific case, our network has only one hidden layer with 3 neurons in that. Next, we defined our activation function. So this activation function, as you remember, that it can be, for example, sigmoid, softmax, the functions ReLU that we talked about. In scikit-learn, logistic is the term that they use for sigmoid. So logistic means sigmoid function. And then I have solver. You defined what type of algorithm the scikit-learn uses to minimize your cost or loss function. Adam and SGD are different. Well, they refer to a stochastic gradient descent. Okay, so I prefer Adam. I put it here. Alpha is your regularization parameter, okay, that we talked about before. So let me show you in the slides. So in the slides, in articles we usually show it with lambda. Okay, this guy right here. is the parameter that adjusts your regularization. So if you increase that, or by increasing or decreasing that, you can penalize the weights and make your network, well, increase or decrease the regularization rate to avoid overfitting. So make it more penalize more to avoid overfitting, or penalize less to let your model be more accurate. So there's a trade-off between this term and this term that you can adjust it with this parameter. And in SciKitLearn, it's called alpha. Okay. We have learning rate that I just talked about, and we had it before again in logistic and linear regression. So this is your learning rate that we talked about. This is learning rate, and here you can adjust it and you can change it. It's 0.1 for now. So this term tells you if you want to see the process of training or not, because it goes over the samples and it can repeat it several times. It tells you if you want to see the process, or if you make it false, then you don't see the process. It just shows you the final results. With this term, you can define when to stop. Okay. So for example, when it is this number, it is the tolerance for the optimization. When the loss score is not improving by at least this value in several iterations, it means that the network will not learn anymore and it can stop. So this is the threshold that the algorithm check to see if your cost or your loss decreased by this value in each iteration or not. If it feels that the amount of improvement in one step is less than this, then it means that the network does not learn anymore and it's time to stop. So if you go to SciKitLearn documentation right here, so it has a pretty good explanation for all of these parameters, and also there are some other parameters that you can adjust. They have default values. So for example, this activation function that we talked about, this is identity function, logistic function, TANH, and ReLU. So SciKitLearn supports these four, and if you see here, logistic function that we used is the sigmoid function, and here's the equation for that. ReLU is another one that we talked about before, rectified linear unit function. Here you go. In Keras and TensorFlow, it's more flexible. We have more other functions that we are going to use. I'm going to show you later. So let's back to the code. After defining this function, the process of training, let me run it and then train it. So the training is similar to other machine learning algorithms that we had, and the same format and the same method, and this method that fit. So you see the iterations over your training data. Okay, so the algorithm used 159 iterations over data, and look at the loss. So this is the loss. This is your loss function, the value. So look at the very beginning, the error was really high. Okay, 0.7 was the amount of error. But every time we trained more and more, the error is less. Okay, so the error value decreases, and as you move forward, as you see, the network rewire its connection and change the weights and the values will be more accurate, so the prediction is better, so the error is less. So as we move forward, you will see that the error is smaller and smaller and smaller, and after 159 iterations we finally reach this value. Okay, it means that the difference between these two, okay, the amount of improvement in error is less than this value. It says for 10 consecutive epochs, so for last 10 in fact this value was less than this, so it is then time to stop, and the algorithm stopped, and now it is very well trained. Let's continue. Let me show you the weights. Okay, so now we can see the weights of our trained weights. So this is the W matrix in fact. So dot coefficients will show you the weights of the network in all layers, and this one dot intercepts attribute, it will show you the bias, the weights for bias values. Okay, bias vector weight matrix. So look, the network that I defined here, it has one hidden layer and 3 neurons. Okay, and we had 9 features. So in the input layer we have 9 values, in the hidden layer I have 3 neurons, so it means that I have 27, 9 times 3, 27 weights for first layer plus 3 for bias, right? So these are 1, 2, 3, 4, 5, 6, 7, 8, 9 times 3. So this is your matrix. This guy is your weight matrix that is trained now. Okay, these are your weights after training, and these are the weights for your next layer. We have only 3 in the next layer of that. These are the 3 values for bias, and this is the bias for the second layer, for the last layer. So these are our weights, and now I can make prediction, and this is the accuracy that I have, 83% accuracy for this network. And the network was very simple, only one hidden layer with 3 neurons. Any questions? Okay, now I want to make the network a little more complex. I will add another hidden layer. So this is the structure of my network now. I will have 2 hidden layers, 6 neurons in the first hidden layer and 4 neurons in the second hidden layer. I have 1 output layer and 9 values for input layer. So 9 input, 6 first hidden layer, 4 second hidden layer, and 1 in the output. And the other parameters are the same. I use sigmoid function for all neurons. I use a stochastic gradient descent for minimization. So it implements backpropagation in fact internally when you train it. Alpha, my regularization value, learning rate, and tolerance. So these parameters, as you see, we have a lot of parameters here. So for example, the structure of the network, how many layers do I need, how many neurons do I need in each layer, what is the alpha, what is the learning rate, what is the tolerance. So these are a lot of values that we have to adjust, and these are called hyperparameters. So one of the problems with artificial neural network compared to other machine learning algorithms is that it includes a lot of hyperparameters that you have to find. And they're not easy. Well, the best approach is brute force, but there are some other techniques to do it. But anyway, we have to spend a lot of time to find the best hyperparameters to get the best results. So with this network, I train my model, and if I print the weights and bias values, you will see that I have a lot of weight. So I had 9 input values. I had 6 values in the first hidden layer. It means that I have 6 times 9, 54 values for the weights of first layer, plus 6 values for bias. For next one, I have 6 here, 4 here, so 6 times 4, 24 values for the weights of second layer plus bias. So as you see, there are a lot of parameters to train. Okay, a lot of weights I have here, and still your network is very simple, by the way, very, very simple. So using this, I can make prediction on my testing set. Making prediction, and you can see the results. And the one very important thing to remember is that you can see the probability too. Okay, so neural network, you remember I talked about it. So the last layer of neural network, especially if you use a sigmoid function, it is exactly like a logistic regression. So it will give you the probability. So this guy is probability of this column is the probability of malignant cancer. So for the first patient, there is 65, 67, almost 68% chance of malignant cancer. For these 3 patients, it's very close to 100% chance. What is this per patient? It's less than 1% chance of cancer, and so on. So you can see this probability, and based on that, we can do ROC curve. So if I implement it, AUC that I talked about in our last lab 2 weeks ago. So in Jupyter Notebook, you can plot the ROC curve. This is what I have using neural network with 2 hidden layers, 6 neurons in the first layer, 4 neurons in the second layer, and this is the prediction results. We can show the confusion matrix. So it tells us how many samples have been classified correctly and how many samples have been classified wrongly. So this matrix 9, 4, 2, 15, I talked about this last semester. It means that there were 9 patients or 9 people that didn't have cancer, and the algorithm correctly classified them. The algorithm also detected that they don't have cancer. There are 15 people that had the cancer, and the algorithm correctly detected the cancer. There are 2 people that had cancer, but the algorithm didn't detect them. And there are 4 false alarms. It means that there are 4 people that didn't have cancer, but the algorithm detect cancer. Okay, so this is the confusion matrix that we talked about. Okay, so let me do it with cross-validation now. Okay, I want to repeat this with cross-validation, and the process is similar to what we had before, and it gives me the accuracy with cross-validation. So I did the exact same thing and define this network and run the cross-validation. It gives me the accuracy of 95%, so which is more reliable when you do cross-validation, of course, because it does not depend on the choice of selection anymore. So how to find the best structure for your network? In other words, how to define the hyperparameters of the network, and also the structure of the network. How do we know how many neurons do we need in each hidden layers? How many, for example, if we have one hidden layer, how many neurons do I need to put in this one layer? So to 100% sure that you come up with the best network, you have to do brute force in the range of interest. It means that you have to try different things. So one of the disadvantages of neural network, one of the issues, in fact, of neural network, disadvantages of using neural network is that you have to do a lot of brute force compared to other machine learning algorithms. So you have to find these hyperparameters, and you have to sometimes find the structure of the network using a lot of trial and error. Okay, so let me show you this approach here in SciKitLearn, which is very popular. Okay, so the SciKitLearn has very powerful algorithms for grid search, and I will show you some other ideas to make the process a little faster, search process a little faster, and by comparing some graphs, the graphs of training, testing, validation, you can get some idea about what is the best range for search, and what are the best hyperparameters, at least what is the best range to put the hyperparameters in, and it can be helpful. So I will explain this after. I will explain that after this. As I mentioned, SciKitLearn has very powerful approaches for grid search, and with this technique, well, it is completely automatic, so you don't need to write a for loop to test different things. Okay, you just need to define the range of search, and then the algorithm will search for you and find the best structure for your network, for your neural network, or the best hyperparameters that you want. You will do it in your next homework. Okay, so in this example, suppose that my first simple network that had only one hidden layer, I want to see what is the best number of neurons, okay, for that hidden layer. So suppose that for this specific problem, I want to make a neural network in SciKitLearn and find out how many neurons do I need in that layer. So I want to search in the range of 2 to 9 to see what is the best number of neurons. And how you define this range, I will talk about this later. Okay. Let's search in this range of 2 to 9. To do that, I will define a list first. Okay. So if I run it, let me run it to show you what it looks like. Print this, run. Okay, this is what I create, in fact. So you create this list, and then I create a dictionary. Okay, well, in this format, let me show you what it looks like again. Okay, so there is a dictionary. The key of the dictionary is hidden layer sizes, and these are the values of the dictionary. Okay, so this is the key, and this list will be the value for that. So we need to define this dictionary. Then you define your neural network. Here, just when you define your neural network, you don't define the number of hidden layers. Okay, just leave it alone. You don't define the neural number of the structure of the network, but you define every other parameters. I also define change this value. So the maximum iteration, you can put a limit on that. The default value is 200, the maximum iteration that the algorithm tries, but you can always change it. So I increase that by 400 because in some cases, one of these things, it needs to go more than 200 iterations. And then this single line will do everything for us. Okay, so this single line, it gets your neural network, which the structure of that is unknown yet, undefined yet. As an input, it will get this dictionary that you just defined here as an input, and I will tell it to do cross-validation with 10-fold cross-validation. Okay, so for each one of this network that you make with this structure, it tries 10 times, okay, to make sure that it is fair. And what parameter used to find out the best structure? Accuracy. Okay, that's it. So we define this grid search. So this is grid search CV, or from SciKitLearn model selection, you import grid search CV, which means grid search for cross-validation, with cross-validation. It creates this network with these different structures, and then tries 10-fold cross-validation for each one of them to see which one provides the best accuracy. So let me run it. Okay. It gives me the accuracy of 95% with 2 hidden layers. So it searched in this range, and it turns out that this network with with 1 hidden layer with 2 neurons. It searched in this range one network with 1 hidden layer. It searched 2 neurons, 3 neurons, 4, 5, 6, 7, 8, and it turns out that 2 neurons provides the best results, which is 95%. Now I want to do the same thing for 2 hidden layers this time. Okay, so I want a network. Let me show you what range I'm searching in. Run it. Okay, so I have 2 hidden layers now. 2 hidden layers. The first hidden layers I search in this range. Second hidden layers I search in this range. Okay, so it means that these are the different neural networks that I try. For example, this guy right here means that a neural network with 2 hidden layers that has 6 neurons in the first layer and 7 neurons in the second layer. This guy right here means that there is a neural network that has 3 neurons in the first layer and 6 neurons in the hidden layer, the second hidden layer. So I will try all of these things to see which one is the best gives me the best results. So if I run it, this time it takes some time, okay, maybe a minute or 2 to find the results, because it has to search. And in fact, it tries many different cases. So remember, 8 different neurons for the first layer, 8 different it's still running. 8 different neurons for the first layer, 8 different neurons for the second layer. So in fact, it creates 64 different networks, and it runs cross-validation, tenfold cross-validation. It means that it tries each one of them 10 times. So in fact, it trains 640 different neural networks and check the accuracy of them. Very powerful. Okay, just this single line for you, just this, it's done. It's done. I'll show you the results now. So this single line alone, it tries 640 different neural networks for you and tells you which one is the best. Okay, so this is the results, the final results that achieve the accuracy of 96% when you have 3 neurons in the first hidden layer and 8 neurons in the second hidden layers. And these are all of the networks that it tries. Okay? So again, this data set is small. When you want to make it, try it on a large data sets, it may take a very long time. But this is a very effective and very popular grid search approach for finding the best structure for your neural network in SciKitLearn.